Hello, my name is Bill McKinley and I'm a strategic planner for Keysight Technologies focused on our cellular V2X solutions. Today I'm going to give you an overview and a demonstration of our C-V2X solutions. Let me quickly go over the configuration that we have today. We have our UXM 5G network emulator running various applications that will test our cellular V2X module. The module that we're testing today is a Qualcomm Roadrunner evaluation kit. What we have also is our MXG, and the MXG is a GNSS emulator. And as you know, GNSS is critical for cellular V2X testing. Not only does it give geolocation, but also is used for synchronization. So let me give you a quick overview. See, we have the GNSS going into the EVK, and we have the transmission for the PC5 connected to the UXM 5G. What I have running at the moment, we have our C-V2X test application. Here we see we have two tabs. The first tab is for our LTE connection for mode 3. The second tab here, which we have active, is our side link tab, and we can see it's highlighted. We have the side link channel on. We can see here that we are able to control and set up the channel as well as GNSS, and the UXM 5G controls the MXG for GNSS, so we are in full control right now for GNSS. A couple of tabs I'd like to show you. Here we're working on the side link, and we can set up what we call our schedulers, both transmission and receive scheduler. These set up the channel parameters for allowing the channel allocations, the resource blocks, to be set for testing in a real-world environment. The other graph I'm going to show is our Blair throughput, and when I start the scenario, we will see the transmission, the packets being transmitted and received as part of the test. So what are we going to do here? We're going to set up a real-world scenario using an application that we have from our partner Nordsys. Let me show you it here. This is our WaveB Creator software, and you can see we have created a scenario based in Germany. And so when we run this scenario, we will see these simulated vehicles actually in action. So the other software I'm going to show you is our WaveB Touch. So once we start the scenario, we're going to see the scenario play out in real time in this map. The third piece of software I'm going to show is our Director application. Now, this Director application essentially controls the whole scenario testing. It synchronizes the scenario, the GNSS, and the UXM 5G to measure and to play out the scenario of interest. So what I'm going to do now, I'm going to use the Director application, which is going to initiate the whole test sequence. So if I press start, we can see the whole startup sequence. So first, the Director application tests the connection between the UXM 5G and the MXG GNSS scenario and the ITS stacks. Once it's confirmed that the connections have been validated, it loads the ITS stack scenario. Now, this scenario is from the WaveB Creator application we saw before. It takes the information from all the simulated vehicles, loads that scenario into instances of the stack running inside the UXM 5G. It then will create the GNSS scenario. This GNSS scenario is a dynamic scenario taken from the maps from the Creator software. The maps will generate a geolocation dynamic scenario that we load into the GNSS emulator, which will be played out to the device under test. So the module considers itself driving around Germany because it's going to be part of the scenario that we created. So here we've run through and we're going to execute. If I now look at the WaveB Touch, we can see the scenario that is being playing out. Let me zoom in a little bit here and we can look in. So we have a junction, we have some vehicles, and at the moment, two vehicles are going to collide. Okay, so the scenario has then stopped. We see the vehicles that were created in the Creator application have played out the scenario. The scenario was a crash, an emergency vehicle came. We could zoom in and we can see the situation in the junction where we have the crash vehicles and the emergency vehicle. let me zoom out again, because one of the questions that we get asked is, can we test a scenario being played out, but in a congested environment? In other words, a stress test for the device, because we need to make sure the device receives the highest priority messages in the presence of multiple vehicles. So I'm going to then go back to my Director application, and I'm going to go to the Congestion tab, and I'm going to start congestion. So we're going to create 100 simulated vehicles in the area of the scenario. So I'm going to start. And if I go back to my Wave B Touch and I expand out, we can see here's the scenario in the center of our image, but we're seeing we have 100 simulated vehicles all transmitting over the PC5 link. So the test would be, does my module under test still receive the highest priority messages in the presence of all these other vehicles? Finally, let me go back to my test application, and I'm going to look at the blur throughput from our transmissions. So if I'm going to go local here, I'm going to start the measurement. So when I start this blur measurement, here I can see transmissions from the scenario. If I go back to my scenario, I'm going to start congestion. What we should see is the transmissions from the congested vehicles that we can see over the PC5 link, the packets that are being created looking at these congested vehicles. So this gives you some idea of the flexibility we have of our test solution. We can create scenarios. We can download these scenarios into our UXM5G GNSS emulator. We can test our vehicle receives and reacts appropriately to highest priority messages. Then we can add in congestion. We can carry out those same tests in a congested environment to make sure that your module truly is ready for the market. Thank you very much.